everybody. Thanks everybody as usual for coming to our weekly tech talks. And good to see that even though I changed the day from Friday to Thursday, we've still got a decent, healthy audience. So thanks for that. Today we've got a very good friend of mine, Karen Lee Rigg. She is from a company called Permutive, which coincidentally is based about 50 meters away from our office in London, although of course none of us are anywhere near our offices at the moment, so that's not directly relevant. Karen is Canadian, but we'll forgive her that obviously. She started her career 5 or 10 years ago now. I think you worked in, was it Bermuda, Karen, for a couple of years?
Yeah, it was Bermuda.
A financial company. Then she came to the UK, worked for another company for a few years. And then when I met Karen was back in 2017 when she joined ThoughtWorks. And the first gig that she did at ThoughtWorks was working with me for her sins, obviously, not my sins. So ever since then, Karen and I have been great friends. She went on to be a tech lead at ThoughtWorks. And then about 6 months ago, was it Karen? She moved on to be a lead engineer, I think is the title, but she can set me right, at Permutive. So this talk is about edge computing. Now, I thought I knew what edge computing was, but then when I was on a WhatsApp with Karen just this lunchtime to just make sure that we understood what was going on, turns out I was completely wrong, and what I thought was the best example of edge computing is something completely different. So I'm hoping Karen, as well as explaining the utopia of data and privacy, she will set right all those misapprehensions and those misconceptions I had about edge computing. So on you go, Karen, and thanks very much for coming.
Sounds good. So let's get started. Right. So thank you everyone for coming. This is my talk, Edge Computing, and I like to call it the Utopia of data and privacy, as it says here. So let's get started by talking a little bit more about cloud computing, right? So everyone knows what cloud computing is. It's been around for like a decade-ish. You've got servers up in the cloud managed by a company. You can spin it up and then you can set it up to do what you want, send data to it, all that kind of good stuff. But what is edge computing? So the official definition, well, I call it official, it's on Wikipedia, which means it's official, right? The definition of edge computing is a distributed computing paradigm that brings computation and data storage closer to the location where it's needed to improve response times and save bandwidth. So I've basically just pulled this image off of the internet because it, demonstrates what edge computing is pretty well. And so you see at the top is you've got your data centers, which is, cloud computing. This is what everyone's quite used to. The middle layer, you've got fog computing. So if you are to Google edge computing right now, you'll get a lot of articles talking about content delivery networks and how, this is edge computing. And yes, it is a form of edge computing in that it is closer to the edge, but it's not like actual edge computing. So content delivery networks is actually considered fog computing. Edge computing is where you have computation being done on devices itself. So that might be smartphones, televisions, refrigerators, cars, I already said televisions. So basic computation that's done much, much, much closer to the user itself. So one thing to note is that edge computing is not going to replace cloud computing. It's going to help with a lot of the problems that we have in cloud computing. So to kind of get started about, what this actually means, and I'm going to go through a real life example, which is what my company does at Permutive, which is using a data management platform. So Permutive has built a data management platform using edge computing. What that means is, so data management platform, for those who don't know, is the name for the platform that you use to determine which ads to serve to a user. So let's go through a real life use case, right? I've drawn this up. On the left-hand side, we have users. So as users, we are users. We might be browsing the internet. We might be reading websites. You might notice, I'm going to see an ad about something. You might have had that creepy experience where it's like you go to the website one time and then suddenly you get ads for it across the entire internet, right? So the way that traditional data management platforms work is as you're browsing the internet, your data is sent up to the cloud, right? So in the cloud itself, in the data management platform, it takes in your user data, it applies segmentation logic. So segmentation is basically the categorization of users for ad purposes. So we might have a segment for cat lovers to say, if someone has, seen pages about cats, then they probably like cats, so let's serve them ads about cats. This is just an example, right? So the way the DMP works is user data, we apply some segmentation logic based on where they've been on the internet, and that puts them to segments. Those segments then get sent to the demand side platform, which is what advertisers use to say, I will pay this much money to display these ads to this subset of users, so this segment of users. And to say, I have a user that falls into this segment, okay, I'm going to serve them this ad, and then that gets sent back to the user. So that's how traditional data management platform works. It's very much following the cloud computing model. So not sure how many people are aware, some issues with this. Right now, advertising relies very heavily on third-party cookies, which is going to die very soon. Google has announced that they're going to be dropping, not support, but basically dropping third-party cookies in Chrome within the next 2 years. So this is like a major thing in the advertising industry. It's a problem. It's a problem. So basically the problem with this model is we are sending our data up to the cloud, and the cloud has everything on us, right? Everything that we do is up in the cloud, and it's actually pretty creepy, right? So let's say, maybe I am a cat lover, I am browsing things about cats, but maybe I also want to browse something about foot fungus because I have a foot fungus problem. Now, foot fungus and cats, not really related, but they have the same data on me. And it's just a bit creepy, personally. So the way that Permutive works is we've pushed the computation for segmentation logic to the edge. So we just kind of like pushed it over to the left here. So what we do is we have our DMP, which allows publishers, people who own websites and stuff, to specify segmentation logic. So we might say, if someone has looked at 3 pages about cats, then they're probably a cat lover and they're going to fall into the cat lover segment. Now, rather than doing this computation in the cloud, we do this computation on the edge. So as you're browsing a website, rather than having your data be sent up, we actually store the data locally on your device. We run the segmentation, we download the segmentation logic, run it on your data on your device, determine which segment you belong to, and then we send that back up. So from that perspective, it's like your data doesn't leave your device. Whether you are browsing about cats or you're browsing about foot fungus, it only matters to who's looking for people in those segments. So this is very high level, like how Permutive works and how data management works and how it's a real life example of edge computing. Not sure if we have time for questions now or if I should do questions afterwards.
I would generally wait until the end for questions, Karen, but
cool. Let's do that then.
Yeah.
Right, so this is just high level how it works. And you can kind of already start thinking about like the benefits of this, right? So first and foremost is privacy. All my data is on my device. My data doesn't go anywhere, but we're still able to make use of the data using edge computing. So privacy, security is a big thing. Scalability as well. So if you imagine in the cloud computing model, if I have a new user and that user is sending data up to the cloud, that's a lot of data as you're constantly using your device, right? But in the edge computing model, if you have a new device, that the data that you send is not as big as it would be because all the computation is done on your end. So it makes things a lot easier. So for example, I'm sure a lot of us have played around with AWS, GCP, Azure, stuff like that. For me, I've played around with AWS free tier, and then it's very, very easy for you to get past that free tier and start, accidentally having to pay money. So for example, I accidentally left an EC2 instance running for a few months and I ended up getting charged like 100 quid for it. So stuff like that, right? And that's just a small example of, the more data you're processing on the edge, the more expensive things come. So with edge computing, it starts to minimize that problem because you're not doing as much computation and it's not as expensive. The other thing is reliability, right? So let's say, Permutive, we have our DMP, we're running on, however many devices, Permutive servers go down and we're no longer able to, do segmentation logic. But the devices themselves still have segmentation logic. So they can continue to work and continue to segment users, even if our servers are down. And then basically they just wait for the servers to come back up and then just send stuff back. So from that perspective, you're cutting that reliance on things being available on the cloud, which generally, not really a problem because, AWS and GCP and Microsoft have done a really good job with, ensuring uptime, but it's just one of those things. The next thing is speed, right? So within advertising, in the cloud computing model, when a user comes to a website and their data gets sent up to the cloud, usually it takes somewhere between 15 minutes and 24 hours to segment a user. And I'm not sure how familiar people are with kind of usage patterns on the internet, but the chances of you being on one website and browsing for a long period of time is actually not that high, especially for publishers, right? You might pop in, read an article, pop out, and then you might come back tomorrow, or you might come back a month from then. But for advertisers or for publishers, they've lost that first opportunity to segment their users and target them with ads. So with edge computing, you have that speed because the way that we've done it, we can target users in real time. So as soon as you've hit that third page of cats, immediately you're in the cat lover section, and immediately you can get served ads for it. And also keep in mind that the whole chatter between the user to the advertiser and then back, it happens in under a second. It's really, really fast. So that's what programmatic advertising is all about. So speed is like a massive, massive thing because it affects performance. If you have a slow website, then people don't want to, use your website, and ads have to happen quickly. And there's a kind of lot to do with efficiency or performance on the internet with that. So the last one is efficiency. So efficiency. One of the questions that I had when I first heard about edge computing was, well, doesn't that kind of take battery power? Don't you end up, sucking the battery power of your users? And actually it doesn't. It actually improves the battery life. So if you take two examples, right? One is you're on a train, you're commuting somewhere, and the internet connection's a bit dodgy, and you're trying to browse the internet. What are the chances of your battery like running low then? Actually pretty high, because it's the network connection that you're trying to download, right? So you can be, if you're using the internet to using your phone to browse the internet, phone dies quickly. But let's say you pop on airplane mode and you play a game, suddenly your battery lasts forever, right? So what we found is actually the battery usage is not to do with the computation power, but actually the processing power for network requests. So from that perspective, it's much more efficient. You don't have like the back and forth. Everything is just better. Now, that's not to say that edge computing solves like all the problems. It comes with its own set of challenges. So these are some of the challenges that we've run into at Permutive. So one is handling low device computing power. So we've only had one instance of this, which is with the Amazon Fire TV Stick. The Amazon Fire TV Stick is quite low spec. It's not that it can't run our SDK, it does, it just doesn't run it in like a super performant way. So what do you do when you have devices that are very, very low spec? Generally not like a huge problem today, because most devices are pretty high spec and can handle running our SDKs. It's just something to keep in mind. The main problem that we have is actually, so the second and the fourth point here are quite related, which is universal device and browser support. So at the moment, Permutive supports web, iOS, Android, tvOS, and Amazon Fire TV. So those are the things that we currently support. But if you think about the combination of things that you can have, it kind of explodes. So I'm actually going to talk about the debugging at scale now as well. So one of the major problems we have is a lot of the issues we don't see during testing, because we can't really write integration tests when you've got so many different combinations of things to test for, right? So we have to support pretty much every mobile device, every popular mobile device. We actually don't technically support like Microsoft devices, but iOS, Android covers majority of it. So all the versions of Apple, all the versions of Android, every single browser that's available for all those devices, and mobile as well. So for all the different browsers, every browser version we have to support as well. So we do have a list of things that we do support and things that we don't support. Obviously stuff like IE6, we're not going to support IE6 because it's a waste of our time, but we support at the moment up to IE11, right? So it's the combination of which device you're using, which browser you're using, which browser version are you using, and then that's just for like browsing the internet, like reading reading websites. What about stuff like television? What about stuff like IoT? So refrigerators, cars, smartwatches. Like we need to be able to support all those things in edge computing. So at the moment with advertising, we've kind of scoped it out, and so it's okay. But this is a massive problem. So the other thing is as well, like I said, with the debugging, generally we don't see problems until we're at like millions of users. So right now on Android, as an example, it's a small portion of our traffic. We're around like the 2 million unique users per day, just for Android. We have so much kind of going on from an infrastructure perspective, the amount of data that we're actually handling, even with edge computing. And so, you know, the way that we get around it is we do canary releases. That's just a way around it, but it's not ideal because, you know, ideally things wouldn't have, like, we wouldn't have bugs that would go out to production. We would be able to test for them, but just because of the nature of it, we're not able to test for it. And then, you know, that's just for web as well. With mobile is a completely different story. So I don't know how familiar people are with mobile development, but with web development, oh, something goes wrong, roll it back, quick, easy. With mobile development, as soon as it's out, it's out. There's no backseas, you can't take it back. The bug is there. And the problem is we have a very long feedback cycle to say something has gone out. We have an SDK. The SDK has to be downloaded by an app developer. Then that app developer has to release a new version of their app to the App Store, and then users have to choose to actually download it. So the feedback loop for figuring out where problems are happening is really, really long. So this is another problem that we, you know, one of the challenges that we've run into. And then the third one is state synchronization. So this is something that's pretty recent for us and something that we're still doing research to try and figure out how to get around. So I can't talk too much about the technical details of it, but I can talk about what it is. So let's say, for example, I have, you know, multiple devices. A lot of people have multiple devices. You know, it's not too uncommon on the internet. You have your MacBook, you have your phone. And if you're browsing the same website, well, you're essentially the same user. Right? So if I look at 2 pages about cats on my phone and I look at 1 page about cats on my MacBook, if I don't sync the states, if I don't sync that usage, then I don't fall into the segment for either one. But actually, as a person, as a user, I am the same user, I should fall into that segment. So, you know, one way to do it is, okay, well then why don't you just synchronize the event data between different devices? Well, then that's a privacy issue, isn't it? Because you might be able to say, okay, I'm going to synchronize the events from one to another, but that means that anyone with your ID number is able to download the same events. So how do you protect against that? So what we're looking at right now is, instead of synchronizing raw events, we synchronize state. So we can say the state of my phone is I have seen 2 pages about cats. The state on my MacBook is I've seen 1 page about cats. Let's synchronize that state and leave all the other event data off the table and just synchronize what matters. So that it in itself is actually, it's very, very complex because there's a lot of algebra involved and how do you combine it, making sure that, you know, we follow the CRDT model, so the conflict-free replication system, conflict-free replication data, forgot the T, but basically saying that, you know, if we send things twice, it knows it's idempotent, and we don't have problems with conflicting data. So how do we do that using the state model? How do we make sure that we maintain privacy? How do we make sure that it's it doesn't cause problems down the line from an architectural perspective? It's quite complex. So this is another one of those problems of, you know, of edge computing. So edge computing actually has been around for a while, but people just don't really realize that it's edge computing. So the most common example of edge computing is probably Face ID. So if you imagine on iPhone, you have Face ID, kind of like, you know, it looks at you, it knows it's you, and it unlocks your phone, right? If it were to follow the cloud computing model, imagine it's like, okay, your phone is going to take a picture of you, send it to the internet, process, and then come back. It's not going to work, right? It's completely ridiculous. It's going to take forever. It's going to cost a lot of money, and it's just not, it's not feasible to do it in the amount of time that a user would expect. So Face ID is actually a prime example of edge computing, where it's a combination of like computer vision, machine learning done on your device. Your Face ID information doesn't leave your device, so it's super, super secure. Another really good example of it is the new track and trace program for COVID that Apple and Google have released for their phones. So people who might have heard about the NHS track and trace program, which was, oh, you're going to download an app, it's going to keep track of your location information and send it up to the cloud, and then calculate who's been in the area and stuff like that, who has come in contact with you, and then send them notifications. That's your traditional cloud computing model. With the track and trace program that Apple and Google have done is basically shifting to the edge computing model, whereby you have an ID number on your phone that rotates every few hours or something like that, so it maintains your anonymity. And it uses Bluetooth. So if you come within range of someone for a period of time, then the 2 devices will exchange ID numbers. And you will keep a track of a list of ID numbers on your device for 14 days, which is the incubation period. Then let's say someone comes down with COVID. What they'll do is send a message up to the cloud to say, hey, I have come down with COVID. These are my ID numbers for the past 14 days. Then your device can check against those numbers to say, have I seen these numbers in the past 14 days? If I have, maybe I should either self-quarantine or get myself checked. And that basically, it doesn't tell you where it happened. It doesn't tell you when it happened, just that you did come into contact with someone at some point who has come down with COVID. So the track and trace program with Apple and Google, significantly more privacy safe or privacy compliant versus the NHS one, which is, they have your location data. They know where you were, when you were there, how long you were there for, and it's just a bit on the creepy side, right? So with a track and trace program, the edge computing model, you're still able to get the same result, but without infringing on people's privacy. So some other examples of where this can be used, and I'm not saying I personally condone this, it's just saying this is an example, would be like surveillance. So let's say if the government wanted to read people's text messages to see if someone might be a terrorist or something like that, right? Rather than having access to everyone's text data and reading through everyone's text messages, well, why don't you just have logic that gets downloaded to phone to say, okay, if this person talks about these things at this time, at this location, then maybe send an alert to say, this is someone to get checked out, right? So it's making use of the data without infringing on people's privacy, and people can still have their privacy, but the government can still keep everyone safe, right? So it's a form of surveillance. I'm not saying that I condone it, I'm just saying that this is a possible use case. Some other use cases would be, industrial usages in factories. Let's say you have a factory where it measures whether it's temperature or like carbon monoxide levels or something like that. You kind of want those things to react in real time. So like measuring metrics and measurements within factories, that's a potential use case for edge computing. One of my favorite ones is actually drones, which is the next one here. So whether it's IoT, so like your fridge, your TV, your microwave, your kettle, or with smart drones, right? So rather than the drones talking to the cloud to say, where should I be? The drone knows, okay, given this set of information, given what it is we're trying to do, I'm going to go here. So this is just a potential application for edge computing as well. And then basically anywhere where you've got like tons and tons of data that is private or sensitive. So health tech, med tech, my industry, ad tech. These are all kind of examples of where you can use edge computing to make use of the data whilst keeping everything privacy compliant. So that's kind of like a high-level summary of edge computing. Anyone have any questions?
Thanks, Karen. Has anybody got a hand up?
Oh, yeah.
Yeah, go ahead, Chris.
Yeah, I'm a bit confused because I'm not quite sure why this is now edge, because this used to be client computing. Edge used to be the stuff you were doing at the edge of the edge of the CDNs, and then this was what we would know as client computing. So calling it edge seems a bit odd. And at least it gives me an option now for finding some other kill files to kind of stop these kind of advertising things actually happening on my devices, because these are very easy. It sounds like it's now an easier option to actually make the ads go away better. Because I don't really, I run ad blockers to try and stop ads running, and if I'm having advertisers running software on my machine, I want to have ways of stopping that happening.
So yeah, I think that's a common kind of, it's not necessarily a misconception, but it's kind of an overloading of the term edge computing, isn't it? So a lot of people use edge computing to talk about CDNs, but actually the definition of it is running on devices. But it's not just
not for the last 5 years. 5 years ago, edge computing was running code on the edge of the CDN was edge computing, and what you're talking about here was called client computing. So there's been a shift of term going on here.
Yeah, there's been a shift of term. So what used to be called edge computing on the CDN is actually closer to fog computing, because while it's closer to the edge, it's not actually at the edge.
Right. Okay.
Yeah. And so like with advertising as well, it's like, I don't know how much this will change people's perception of advertising. Like I also run ad blockers despite working for an ad tech company, but I run ad blockers not just because I don't want to see ads, but just for privacy reasons. But if I know that actually, my data is safe and it's not being sent up somewhere else, and it's actually all the computations happening on, I own my own data, it doesn't leave my device, it makes me feel a lot better about it. And then also knowing that like the advertising that I would potentially be blocking is actually blocking revenue for the publishers that are creating the content that I'm reading. So from that perspective, it's like kind of unfair that they're just kind of giving things away for free. Like, you know, if I'm going to be reading something on a website that someone spent a lot of time to write up, then, you know, what can I do? Well, if it's just being served ads, like I'm personally happy to see ads if it means that my data is safe. That's just me.
Yeah, it's a balancing act of the edge being the kind of offensive detail that some of the ads go into. Does this new ad thing actually, given that they're going to be dropping third-party cookies, this makes GDPR stuff kind of rather interesting?
Yeah, so our founders actually saw this coming. We just didn't expect it to happen so soon. And so that's kind of why we built an ad tech platform based on edge computing. So we don't rely on third-party cookies at all, right? So the way that we work is with first-party data. So if you're browsing a website, that website only has data on your usage on their website, not your usage on other websites. And so you only get targeted. Your ads are you're only targeted using ads that are based on the data that they've got. So from that perspective, like we're much more privacy safe. We don't, you know, track people across the internet, but we're still able to make use of the data that we that publishers have in a privacy compliant way.
Okay. Thanks, Chris. Phil, did you have a question?
I did, yes. So I'm curious about one thing. One of the big challenges with the sort of current model, not just advertising, but it is, of course, one of the biggest data collection exercises that we have right now. One of the big challenges is where your advertisers, like Google and Facebook, are also at the same time your identity providers, like Google and Facebook, so that they not only know that I am in the cat lovers category, but they also know that I am Phil and I'm living at this address and I have this phone number and this email address. And so it's almost impossible for me to tell whether and how they might be connecting this data. Does, in your view, doing the segmentation at the edge change anything about it, or is it just the world we live in now?
So I think that that's a tricky one, isn't it? Because it's like it's Google and Facebook, right? So that's actually something that we're seeing shifts with Apple in general, and Google's kind of following suit. So one thing that Apple has done is they're getting rid of IDFA on iOS. So IDFA is the identity. It's basically their third-party cookies on iOS. I forgot what IDFA stands for. So it's like their third-party cookie where you can get tracked across different apps. So they're actually getting rid of that. And so they announced that, I think, about 2 weeks ago or so. So Apple is very much moving in the direction of like privacy first. Stuff like Google. So Google is kind of following suit. So with the announcement of dropping third-party cookies in Chrome, that's kind of a big thing. But it also doesn't change the fact that, you know, you log into the Chrome browser with your, you know, Gmail and you get tracked across the internet. I don't know how that's going to turn out. I don't know how it's going to pan out. So part of me says, like, you know, it probably is the way it is. Also, you know, it's in their best interest to continue collecting that data. It's not, you know, privacy compliance is not exactly, you know, it doesn't really work for their business model. Don't know how they're going to get out of that. But, you know, eventually what I'm expecting is people are going to start caring more and more about privacy, and maybe there will have to be a cultural shift based on that. But it's, I think, a combination of what you said of like it kind of is something that you do need to just kind of accept, just it is the way it is, but also there are solutions out there that could make it better.
All right, thank you.
So I have a quick question, Karen. So if I've understood this right, and there's a good chance I haven't, because as you know me, are you making like an SDK which gets passed down? So are you therefore, we've mentioned IoT stuff, we mentioned mobile devices, we mentioned internet stuff. So does that mean that you've got basically, if I've got a website and I want to have some ad technology on it so that I can maximize my revenue, am I then importing a JavaScript library and executing that in much the same way as I would do with other libraries?
Yeah, exactly. So we work very similar from that perspective of we have a bit of JavaScript that downloads our SDK from a CDN. And then in that SDK, in web is different from in mobile. In web, when you download the SDK, it also includes the segmentation logic for that particular publisher. And so it kind of like runs all in one, it spins up, it starts tracking what you're doing, it saves your events in local storage, runs a segmentation logic, and then sends that stuff back out. We update every, I think, 5 minutes. We have like a cache bust for that. On mobile, it's a little bit different where we ship out SDKs. So that's what I was talking about earlier, where once it's shipped out, it's out. You can't do anything about it. You can't take it back. It's, you know, out there forever, set in stone. So for that, it's just the SDK logic, but the segmentation logic does get downloaded from a CDN.
So if I'm a publisher, does that mean that I take the core product and then I have to code my own segmentation logic?
Yeah, that's right.
Right.
So we, you know, we have solutions architects that kind of help with that, with the deployments. You basically have a bit of JavaScript, or you kind of download the SDK onto your app, you install that, and then, you know, you go into the Permutive dashboard to then identify different segments that you can, you build the segment logic yourself. So we actually have query language that we've built to write these queries. So you build the segments, and then at the moment, the model we have is the publishers then go sell these segments to advertisers.
Right. So now I'm struggling then back to Chris's question, really, because I'm struggling to see how that's different from when my browser downloads something like React and runs some React code in the browser.
So the difference is that the segmentation logic is dynamic.
I see. Right. So if I run something like React, so what we're saying is that I'm getting some specific code somehow and that's why it's edge computing rather than everybody getting the same codes, which would be.
Yeah, that's right. So
okay.
If a publisher decides they want to update their segments, that as soon as they like press save, within 5 minutes, all their users have it.
Right. Okay. And that code might be different depending on my own personal data, because is that right? So I'm sending up, I'm saying I'm a cat lover or a cricket lover, and I'll get different code downloaded depending on those things?
Depending on which website you're on.
Right. Okay.
So if you're on like a news site versus, you know, maybe like a different news site, let's say like just as an example, like New York Times versus like The Economist versus like BuzzFeed, each of those websites will have their own segmentation logic. So your traffic is not shared between them. Right. So they only know what you've seen on their site. So that's first party data.
Okay. I'd be disturbed if the New York Times had ever heard of cricket, but there you go. Okay, thanks for that. Do we have any other questions? Any hands up? Phil again, go ahead, Phil.
If we've got time for one more.
Yeah, we've got plenty of time. We've still got 25 minutes, so we can chat for a while if you like.
Since we're talking about advertising, and this is something that I've been involved in a previous life a little bit, I'm curious, how does the way that you do the segmenting and the ad serving, how does that work, if at all, with programmatic ad brokering? If I'm a publisher and I want to take part in one of these programmatic ad brokering platforms, can I do that? Does that work? And if so, how does it work?
Yeah, so everything that we do is programmatic, or it can be programmatic. So we actually hook into a lot of other service supply side. No, sorry, we're the supply side. We hook into a bunch of demand side platforms as well. So, you know, stuff like Google Ads. What else have we got? I don't deal too much with them, but basically we have a bunch of other integrations that we do have. That currently does exist. We're actually looking to build our own demand side platform right now. So we're talking to some advertisers about that. But yeah, I mean, ad tech is, I mean, you know, since you've been in ad tech, I've only been in ad tech for half a year, so I'm not 100% on all the details, but if you want, I can get back to you on that.
I'm just curious because I've been involved in some of the sort of challenges that you get into when you do this high frequency brokering off of ad slots.
Yeah.
Literally, you have to find a person who wants to serve an ad to this particular user, and you have to do it within the 200 milliseconds that you have before the video starts.
Exactly.
And the whole like real-timey aspect of it is very interesting to me.
Yeah, so I mean, I'm definitely not the best person to speak to it, just because I'm the engineer manager for the Edge platform itself, so very, very much supply side. But if you want, I can get you in touch with some of our sales engineers or solutions architects who can talk a little bit more about the demand side of things.
Cool, thank you.
Great. Any other questions now? Okay, Phil, have you come off mute again there, Phil? No, you didn't. Just looking around, looking around. Okay. Okay, so I think we're at the end of the discussion. I'll just say, having seen all that, I'd like to, I'm still not entirely clear, you know, I think when I looked at the Permutive website, when you first joined Permutive, Karen, I was interested because not really understanding the difference between what you've called the edge and what you've called, was it fog computing? It seemed weird to me that these things were happening, but now I think, yeah, to me the exciting part is that whole privacy concern, which is what you've talked a lot to, isn't it? And I'm interested to see where it goes with Phil's question as well in the long run about when the identity provider is also the ad server, because it seems to me that yeah, there's some sort of scary overlap there, which I still think I don't fully understand. But yeah, fascinating subject. No doubt, if any of us come across this type of stuff in our gigs, I'll put people onto you, Karen, or at least onto your company. Okay, so before I close the call, is there one last opportunity for any more questions for anybody? Okay, gone. All right, so everybody, thank you very much for coming to the talk. Big thank you to Karen. Thank you very much, Karen.
Thank you.
I nicked this from a gig that Karen was on as well when we were at ThoughtWorks. We invented jazz hands as a way of giving applause at the end of calls because we always have video links. So for everybody on the call now from Codurance, in 2 weeks' time, back to the Friday slot, we have got Andrea Rendell from Satalia. They are basically a machine learning data science type company, one of our partners. And she's going to be talking about optimization algorithms, which I'm really excited about. But unfortunately, I'm going to be on holiday that week. So somebody else will be hosting that meeting. But as usual, we'll record it and I'll watch it back when we come back. So thanks once again, Karen. Thank you for the great talk. Thanks, everybody, for coming. And we'll see you again in a couple of weeks. Goodbye, all.